Alright, so this is a lab we would have done in class had we actually had class. So if you haven't done it, um, go ahead and pause the video. It's on Moodle. There's a blank copy that you can work through, and then the answer key is right below it. So we're going to go through the answer key um, so you can follow along after you've done the work. Once again, it's not going to be a grade, but it's really good practice. One of the biggest problems students run into with this unit is they use the wrong formula. Okay, so make sure that you're using the correct formula to solve the problem. All right, so question number one, we've got $2,000. We're going to put an account. We're getting 3.5% interest. We are going to leave it there for 15 years. So this is just a simple interest deposit, leave it, not touch it again. So the formula for simple interest is the principal plus parentheses the annual percentage rate times the principal times the year. Okay, some people just like to do it the interest separate and then add it to the principal. You can do that. So 2,000 principal times 3.05 interest times the 15 years would give you $1,050 of interest. Add it to the $2,000 you started with, and you have $3,050 in your account. All right, second one. We are looking to create a college fund for your child. If we want $90,000 in 15 years, we're getting 5% compounded monthly. Okay, so the monthly formula is the principal times 1 plus the interest rate divided by the number of times it's compounded. So remember, quarterly was 4, daily was 365, monthly then would be 12. So 12, and in this case it's going to be 12. Years is 15. So 90,000 equals the principal. We're going to plug everything else into the calculator just like it is. Don't forget parentheses. We get 2.114, and then 90,000 divided by 2.114 is $42,579.28. So that is how much you would need to deposit right now. All right, so kind of a follow-up question to show you how important interest is. If everything stayed the same, but I got 12% interest instead of 5% interest, so now we're going to put 0.112 or 0.12 in for our A. 90,000 equals the principal times 5.996. And now we only need to pay, only being, kind of relative here, but $15,010.50. Okay, so if we get 5% interest, we got to put $42,000 in. If we get 12% interest, we have to put $15,000 in. That's a $30,000 interest, or $30,000 different in principal to get the same $90,000  15 years later. All right, number 3. We are putting $25,000 into an account. We're getting 3.3% interest, and this one is compounded quarterly. So same formula as before. Principal is $25,000. 1 plus APR is 0.003. Quarterly, though, is going to be 4. So N is 4 in this case. And then raised to the 4 times 27. Everything can go into the calculator. And after 27 years, our $25,000 has become $60,716.81. All right, number 4. If we deposit $10,000 into account at 4.1 compounded continuously. How much do we have at 5 years? So the continuous formula, that is the one that says has E in it. So anytime you see the word continuous in the problem, you know you have to use the formula with an E. So 10,000 times E raised to the 0.041 times 5. And remember, that's the E button that's to the left of the 4 if you have a TI 83 or 84. Okay, so second ln will get you your E. That's the one you got to use. And 5 years after that, we're going to have $12,275.25. All right, number 5. We have $10,000 we're going to invest. We are getting 9.1% interest, continuous or quarterly. So what's the difference? So continuous, that is E. So it's going to be 10,000 times E raised to the 0.091 times 20. And we would have $61,718.58. If we do quarterly, a quarterly or compounded something other than annual, it's principal parentheses 1 plus the APR divided by the number of times it's compounded. Quarterly would be 4, raised to 4 times 20. So everything can go in the calculator. Keep track of your parentheses. If you want to make 4 times 20, 80, and just plug 80 in, you can do that. And quarterly would get you $60,472.66. Okay, so the difference between compounded continuously and compounded quarterly is $1,245.92. Remember, the more often it's compounded, the more interest is accrued. So that's good if you are investing. That is bad if you are paying the bills. All right, number 6. All right, we want to have $50,000 in 6 years to put a down payment on the house. We can get 7.3% interest. It's going to be compounded monthly. So we're looking for the principal. So 50,000 equals the principal. 1 or P times parentheses 1 plus 0.073 divided by 12, close parentheses raised to the 12 times 6. So we're going to put the right side in the calculator. Don't forget parentheses. And if you want to make that 12 times 6, 72, that'll probably make life a little bit easier. That comes out at 1.548. Divide that into 50,000, and you would need to put in $32,299.74. Okay, and then in 6 years you would have $50,000 for down payment. All right, if I have $24,000 and I put it into an account at 11.4% interest, compounded quarterly, how much do I have after 26 years? So 24,000. Hopefully the formulas are getting a little bit easier. Parentheses 1 plus 0.114. Make sure when you convert decimals to percents or percents to decimals, it's 2 decimal places. Okay, so 0.114 divided by 4 raised to the 4 times 26. And your $24,000 26 years later would be $446,126.51. It's just sitting there letting it compound interest over the years. All right. Number 8, 4,000 into an account that pays simple interest at 2.5% for 17 years. First off, if you're putting it in for 17 years at simple interest, you better be getting more than 2.5%. I'm just saying that's a lousy interest rate, and you can kind of see that. So simple interest, it's our principal plus the interest rate times the principal times the years. We would get $1,700 in interest, and our $4,000 has become $5,700. Simple interest, really easy to calculate, not very good return if you're investing. All right, number 9. Back to our house payment. We have 8.1% interest, compounded monthly. We want to have $60,000 in 7 years. So that would be the amount we are looking for the principal. We want to know how much do we need to deposit today. So 60,000 equals the principal, parentheses 1 plus 0.081 divided by 12 times 12 times 7. And we would get 1.760. We divide that into 60,000, and we would need $34,098.37 today to have 60,000 in 7 years. All right, number 10, 11,000 with a 4.2% interest rate. How much do we have in 5 years? Notice it says continuous, and continuous automatically means E. So 11,000 times E raised to the 0.042 times 5 means we would have $13,570.46. All right, number 11, we have $12,000. We're going to put it into a CD, simple interest. We want $15,500 at the end of this in 4 years. What interest rate do we need? Okay. This one's a little bit different in that we're trying to find the interest rate now. All right, so we would have 15,500 equals 12,000. Oops, left off a plus sign there. Plus parentheses the interest rate times 12,000 times 4. We would then subtract. So 15,500 minus 12,000 would give us 3,500 equals 48,000 times the APR, and 3,500 divided by 48,000 is 0.0729 or 7.3% interest. So we would need at least 7.3% interest for 12,000 simple interest to become 15,500 over the 4 years. All right, and if I put $3,000 into an account, and I can get semi-annual at 13% and continuous at 13%, what is the difference of the annual percentage yield? So let's start off with the semi-annual. So the principal, parentheses 1 plus interest rate, 0.13, divided by n. Semi-annual means twice, so n would be 2. And we're doing an annual percentage, so y would be 1. Plug everything in the calculator, we would get $3,402.68. So the APY, we take the increase. So we went from 3,000 to 3,400, so we had an increase of $402.68 divided by the principal, times it by 100, and we were getting an annual percentage yield of 13.423%. All right, we're going to compare that to the continuous. So continuous means E. So 3,000 times E raised to the 0.13 times 1 year means we have $3,416.49. Okay, once again, the more often it's compounded, the more interest you will earn. So we had an increase of $416.49. Divided that by 3,000 times it by 100. And the APY, the annual percentage yield, is 13.883%. That's a difference of 0.46. So you get almost 0.5% more yield per year if you get continuous versus semi-annual. Okay, so that's all the problems. Once again, hopefully you can start using, make sure you use the correct formula. That is the biggest, probably biggest mistake on this test, is using the wrong formula for the problem that asked. So continuous is E, simple gets its own, and then everything else would be the compounded, semi-annual, annual, monthly, daily, so forth and so forth.